Hey grade 12s, and welcome to the second video in a series of videos on coordinate geometry, and this is in additional mathematics. And so let's get into doing some math. So in the first video we looked at finding the midpoint, calculating the midpoint between 2 points, and in this video we'll go a step further and learn how to find the distance between 2 points. So let's start from something quite basic. I believe let's just revise a bit of what we did in our grade 7, or is it 9? So let's say we have this triangle, and you are told to say this is a right angle triangle. Remember what a right angle triangle is? Right angle triangle has a 90 degrees angle in one of its vertices. So meaning this right angle triangle that we have has a 90 degrees somewhere, and the 90 degrees is given there. And if you recall well, I believe you can remember to say in grade 9 and grade 8 we agreed to say the longest side of a triangle is known as the hypotenuse, and we've got the opposite as well as the adjacent. Remember that? And we said to find the hypotenuse, we would say we employed what is known as the Pythagorean theorem, which states to say the hypotenuse squared equals the opposite squared plus the adjacent squared. Remember that? And so let's assume we do not have these hypotenuse and we do not have the opposite, nor do we have the adjacent. And we replaced these with letters. Let's say we've got side A, got side B, and we've got side C. The Pythagorean theorem will still hold for as long as this triangle that we have is a right angle triangle. And so we'd have a squared equals b squared plus c squared. Are we together there? I really hope so. So now let's apply this knowledge that we have built on from grade 8 and grade 9, and let's apply this in coordinate geometry at grade 12, or rather senior secondary level. So remember, in the previous video we agreed to say in coordinate geometry we have a Cartesian graph, Cartesian plane of such manner. Okay? And we agreed to say we've got the y-axis, which is vertical. Then we have the x-axis, which is horizontal. So now let's assume to say we are given points. We've got a point there. Let's say this is point A, right? And we have another point somewhere up there, and this is point B, and we are given the coordinates of points A and B. Point B has the coordinates of 3, 1, whilst point A has the coordinates of -1, -2. -1, -2. And you're asked to find the distance between point A and point B. So the first thing that we would do is join these 2 points. We'll join these 2 points, point A and point B, by drawing a line stretching from point A to point B. Right? Then upon doing that, let's also draw lines that are cutting the x and the y axis. So let's say we start from that point. So this is the x line parallel to the x-axis that's cutting through the point where cutting through the y-axis, and we have another parallel line, this line being parallel to the y-axis, that is cutting through point B and cutting through the x-axis as well. So we'd have such lines, and we'll do the same for point A. We'd have a line cutting through the x-axis, and cutting through point A, and we would have a horizontal line cutting through the y-axis and cutting through point A. You see that? And if we take a close look at what we have, you'll notice to say we have, let's use blue for that. Okay, let's continue with the red. We have a triangle. Okay, sorry for that. We have a triangle that has been formed. Our triangle being in red, we have this triangle that has been formed. We've got triangle A, B, and we would have an imaginary point that would name as point C, where this vertical line and this horizontal line are meeting. And so we have a triangle in such a manner. Can you see it? Triangle A, B, C. And going back to the Pythagorean theorem, if we are to find the distance between point A and B, this line AB would be our hypotenuse, and line AC and line BC would be our opposite and adjacent respectively. So to find this distance, we would first need to find the distance AC as well as the distance BC. So if I was to ask you, what are the coordinates of point C? So point C in the x-axis is lying at point 3. So we'd have 3, comma. In the y-axis, point C is at -2. So we'd have 3, comma, -2. Right? And so the distance from here to here can be found, as well as the distance from here to here. So distance AC will simply be found by subtracting the x coordinates of A, or rather of C from A, or of A from C. So to find this distance, we would say, what are the x coordinates? We've got -1 and 3, so we'd say -1 minus 3, -1 minus 3, or maybe let's say 3 minus -1. So AC equals 3 x coordinates, the value of the x coordinate of C is 3, minus the value of the x coordinate in A is -2. Sorry, -1. Sorry for that, -1. And therefore AC would then be equal to 4. So the distance from A to C is 4 units. The distance from C to B, or B to C, would then be, because B and C are both lying on the same x coordinate, then the distance can be found by using the y coordinates of B and C. So BC equals, the y coordinate of B is 1, 1 minus the y coordinate of C is -2. So 1 minus -2. And that gives us 3. So this distance BC is 3 units. And so this has just made our work really easy. And we would find this distance AB by applying the Pythagorean theorem, which states to say the hypotenuse being the longest side is equal to, the hypotenuse squared is equal to 3 squared, or rather the opposite squared plus the adjacent squared. So we'd have AB squared equals AC squared plus BC squared. So AB squared equals, what is our AC squared? Or rather, what is our AC? Our AC is 4, so we'd have 4 squared plus, what is our BC squared? What is our BC? Our BC is 3, so we'd have 3 squared. So AB squared equals 4 squared is 16 plus 3 squared is 9. AB squared equals 16 plus 9 gives us a 25. And therefore AB equals the square root of 25, which is 5. So the value of the distance from A to B is 5 units. So maybe this proves to be a bit complicated, but let's look at another example and we will be able to open and make our brain cells understand this concept a bit more clearer. So before we look at the next example, let me just mention to say, if you are asked to find the distance between 2 points, we can generally write a formula that can help us. And this formula is distance d equals, or maybe let's say d squared equals the x coordinates, difference in the x coordinates squared plus the difference in the y coordinates squared. But what we're looking for is not d squared. What we're looking for is the value of d. So we can square root that and we would have d equals, if we place the square root there, it means we place the square root on the other side as well. So we'd have this is equal to square root of x minus x squared plus y minus y squared. And let's indicate y, x1, x2, y1, y2, x1, x2, y1, y2. So this is the general formula that we are going to use to find the distance between 2 points. And we should note to say this distance is coming from, or is being derived from, the Pythagoras Theorem, which states to say the hypotenuse squared equals the opposite squared plus the adjacent squared. And we agreed to say, from the previous example, we found that the distance in the y is simply equal to the difference in the y, and the distance in the x is simply equal to the difference in the x. So now let's look at a few examples that will help us understand this concept a bit more clearer. So here we are, friends. We are given a question, and the question says, find the distance between A, 7,13 and 2,1, B, 2,-3 and -3,4. So how do we go around and how do we go about tackling this question as Addma students, as additional mathematics students? So here's how we do it. So solution. So let's start with A. So for A, we are given 2 coordinates. We've got 7,13 and 2,1. So I'm going to teach you a simple and easy way that can help you get more accurate answers as you tackle such questions. So the first thing that you do, just as we were doing in the midpoint analysis, we said you first start with writing x and y. Okay, then we collect the coordinates that we've been given. So for the first one, we've been given 7, 13. And for the second one, we've been given 2, 1. And to find the distance, we agreed to say distance is simply equal to difference in the x coordinates squared plus difference in the y coordinates squared. So to avoid confusion, we write down our coordinates in such a manner, okay? And we pick them just as they are, okay? Just as they are. So we've got the x coordinates, 7 and 2. So we'd have 7 minus 2 squared plus, we pick the y coordinates, and we would have 13 minus 1 squared, right? And 7 minus 2 would give us, 7 minus 2 gives us 5. So we would have 5 squared plus 13 minus 1 gives us 12 squared, right? And let me continue here. We would have distance equals 5 squared gives us 25 plus 12 squared gives us 144. 25 plus 144 gives us 169. And the square root of 169 is 13. So our distance between these 2 points is equal to 13 units. So key thing is you collecting and writing your coordinates down in this form. Then you collecting and remembering, most importantly, remembering this formula, which is difference in x squared plus difference in y squared, root of the sum of the two. And once you do that, it's easy peasy from there. All you have to do is just insert the values that you've been given and you will get the answer. So let's do number 2 together. Let's do question B together. So for question B, we are given 2 coordinates as well. And we have 2, -3 and -3, 4. So the first thing is x, y. First coordinates, 2 minus 3, comma. Second coordinates that we have is -3, 4. Remember, the formula, the equation that you have to remember is d equals root of difference in x squared plus difference in y squared. Then from there, it just goes down here from there. And all you have to do is replace the x values, replace the y values, and you get your answer. So you will have root of x minus x, so we would have 2 minus -3. So 2 minus -3, and we have brackets squared plus difference in y would have -3 minus 4 squared. So 2 minus -3 gives us, it's all the same as 2 plus 3, which gives us 5 squared plus -3 minus 4 gives us -7 squared. And we would have d equals root of 5 squared gives us a 25, whilst 7 squared gives us 49. And 25 plus 49 gives us root of 74. Now 74 isn't a perfect square, and so we wouldn't get we wouldn't get our whole numbers as the square root of 74, and therefore would leave our answer at that. So root of 74. And that is how we find the distance between 2 points in coordinate geometry. So let's look at 2 more examples, and we'll call this, will be done with finding the distance between points in coordinate geometry. So here's a question, and the question reads, the vertices of a triangle ABC are A, negative 2, 5, B, 4, 4, and C, 5, negative 2. Which is the longest side? So I want you to pause the video and just try to figure that out and try to solve, and you try to tell me which one, you try to say which one is the longest side. Otherwise, let's do it together, even as you have tried it on your own. So the vertices of a triangle are A, B, C, and A, B, C. So in short, we have a triangle with vertices A, B, and C. And we're asked to find the longest side that the triangle has. Is it side AB? Is it side AC? Is it side BC? So what we need to do is find the distances, find all 3 distances around this triangle, that is AB, BC, and AC. And then we try to see which one has the largest value. So let us get into doing this question together. So we've got AB, we've got BC, and AC. So let's start with side AB. So we know that, going by what we've learned by the Pythagoras Theorem, we know that to find AB would have AB squared is equal to x minus x squared plus y minus y squared, right? So for AB, what are the values of x and y? So we've got x, y, and the coordinates of A are negative 2, 5, 5, whilst the values of B are 4, 4, 4, 4. So we write that equation there, and this time we replace the values with the variables with the coefficients, or rather with the values that we have there. So for x, we're going to say negative 2 minus 4, minus 2 minus 4, this is squared, plus, for y we'll say 5 minus 4, and this is also squared. So for AB, we are going to have minus 2 minus 4 gives us minus 6, squared gives us 36, plus 5 minus 4 gives us 1, squared gives us 1. So therefore, the length of AB is 37 units. So for AB, we've got 37 units. Let's come to BC. So for BC, we're going to have to do the same. So x, y, and what values do we have for the coordinates of B? We've got 4, 4, 4, 4. And for the value of C, the coordinates of C, we've got 5, negative 2. So we've got 5, negative 2. So we do the same. BC this time, squared equals, or actually, okay, anyways, let's continue. So BC we'll say 4 minus 5. So this is unit squared because we still have the squared there. We haven't gotten rid of the squared. So u squared, so 37 unit squared, 4 minus 5 and squared plus 4 minus minus 2, 4 minus minus 2 squared. 4 minus 5 squared, 4 minus 5 gives us a negative 1, squared gives us 1, plus 4 minus minus 2 gives us 6, squared gives us 36. So 1 plus 36, which is 37 units squared as well. And we come to the last one, which is AC. So we've got X and we've got Y. A, coordinates of A, we've got negative 2, 5. Coordinates of C, we've got 5, 2. 5, negative 2. 5, negative 2. So AC equals, so sorry, this is BC, so 37 as well. AC equals X values. So AC squared equals X values, negative 2 minus 5 squared plus Y values, 5 minus minus 2 squared. Negative 2 minus 5 gives us negative 7. Squared gives us a 49. Plus 5 minus minus 2 gives us 7. 7 squared gives us 49. And 49 plus 49 gives us 98 units squared. So which among the three sides is the longest? So clearly the longest side is AC, which has 98 units squared. So the longest side is AC. And I really hope that's what you got, because this was a straightforward question. And we can look at the last example on this subtopic. So here's the last question, and I want you to pause the video and try working it out on your own. So here's how we work around this question. The question says a circle has center at 1, 2. 1 point on its circumference is negative 3, negative 1. What is the radius of the circle? The circle has radius, has center at that, and 1 point of on its circumference is that. What is the radius of the circle? So here's what we have. Here's an illustration of what we have. So we have this circle, and we are told to say it has, let's say our center is there. It has a center there, and let's do a bigger circle. Here's our circle with a center that's there. And we're given the coordinates of the center of the circle. So the center of the circle is at 1, 2. And we're told to say 1 point on its circumference is negative 3, negative 1. So let's say this is the point. This point has negative 3, negative 1. And we're asked to find the coordinates, and we're asked to find the radius of the circle. Now, grade 12s, I need you to understand to say, when you hear the term radius, we are simply talking of the distance from the circumference to the center of the circle. So we're simply finding the distance between these 2 points. So now that I've said that, I believe this makes our work really easy and we can tackle this question. So let's do it together. So let's do it together. So we are given to say, so here's our solution. We are told to say this circle has its center at 1, 2, and its circumference is at negative 3, comma 1, right? We're asked to find the radius, which is simply the distance between these 2 points. So same principle applies. D equals root of difference in the x squared plus difference in the y squared. So what is the difference in the x? In the x we have 1 minus 3 squared plus, in the y we have 2 minus 1, and this is squared as well. So what we get there is 1 minus negative 3 gives us 4, and 4 squared gives us 16. 2 minus 1 gives us 1, and 1 squared gives us 1. So therefore we have root of 17. Now 17 isn't a perfect square, so we wouldn't easily find the root of 17. So we would leave our answer as root of 17. So the radius of the circle is root of 17. So I'd encourage you to find questions that you can try to work on your own under this subtopic of distance between 2 points in coordinate geometry, and see you in the next video as we will look at a bit more of coordinate geometry. So stay safe and thank you.